Hey, so today we're going to be talking about balancing chemical equations. It's very simple, very easy to do. Helps you figure out how solutions are going to work and what's going to happen when you mix molecules together. So let's start off with an example. This is what happens when you mix zinc and hydrochloric acid. So see you got zinc plus HCl on this side, and on the right side, which is the result or the products of the reaction, is zinc chloride 2 and hydrogen 2. So what you do to balance these chemical equations is you want to make sure you have the same number of atoms on both sides. So on the left, you see we've got one zinc. On the right, we also have one zinc. So that's good. We can leave that be. Then on the left, we've got one hydrogen. On the right, we have two hydrogens. So we're going to have to go back and fix that. Now you see we've got one Cl on the left and two Cl's on the right. So again, we're going to have to fix that. An easy way to fix it, if you can see, we add molecules to it. So in this instance, we add a second hydrochloric acid molecule to the equation. So we have one zinc, that's right. Then we have the two hydrogens, because the two will apply to the hydrogen. So two hydrogens on the left, two hydrogens on the right. That's correct. Chlorines, we got two chlorines. It applies to that one as well. So two chlorines on the left, two chlorines on the right. And so that's all of them. And so that one is balanced. That equation is balanced, and that one is correct. So let's go on to the next example. This one we've got 8 sulfurs, 2 fluorines, and then SF6 on the right as the reactant, or as the product. The reactants are on the left, products are on the right. So we see we've got 8 sulfurs on the left and 1 sulfur on the right. So that's going to have to change. We have 2 fluorines on the left and 6 fluorines on the right. Now this poses a problem, of course, because we see that over here on the left, we have way more sulfurs than we do over on the right. But we have way more fluorines on the right than we do on the left. Well, we can't go less, so we have to add to it. So we put an 8 over on the right side, and so there are 8 sulfurs, 8 sulfurs. But because there are 6 of these, 8 times 6, we have 48 fluorines. 48 fluorines on the right and 2 fluorines on the left, sorry. So that doesn't work. So we add a 24 to this side. So we have 8 sulfurs, 24 times 2, 48 fluorines, 48 fluorines. So that one, although it has these ridiculously high numbers, it actually is balanced. Because you'll notice there's nothing in front of the sulfur on this side. Alright, last example. I'm going to show you one of the great things about balancing chemical equations is that there is actually a way to check yourself very simply through this. It has a built-in checking method. So on the left we have 1 potassium, on the right we have 1 potassium. On the left we have 1 nitrogen, on the right we have 1 nitrogen. On the right we have 3 oxygens, on the left, on the left we have 3 oxygens, and on the right we have 4 oxygens. So that's going to have to change. The potassium and the nitrogen work well on both sides, but the oxygens need to change. So to fix that, we'll have to add oxygens to it. So we add 4, because we know that 4 of these potassiums, and then we can add a 4 to these, and those will be balanced. Now we've got 4 nitrogens over here, so we'll have to add a 4 here as well. Then 4 times 3, we've got 12 over here. So then what we'll do is we'll add a 4 here, so the potassiums are equal, nitrogens are equal. Oxygens, we've got 12 oxygens on this side. We've got only 10 on this side. So to fix that, we're going to have to throw a 2 over here. Now this is the checking method I was telling you about. You see, these are a lot of high numbers, and we don't want to add a lot of high numbers. We'd like to do this as simply as possible. So what you look at is what number can all of these coefficients be divided by? The 4, and the 2. And we see that 2 goes into all of these. So let's see what would happen if we divided all those numbers by 2. So 2 potassiums, 2 nitrogens, 2 nitrogens. 2 times 3, 6 oxygens. 2 times 2, 4, 5, 6 oxygens. So a very simple way of checking yourself. You just see if you've got numbers on all of them, and they can all be divided by the same number, higher than 1 of course, then you simply do that, and it will simplify your equation. Alright all, that's everything I've got. So that's a crash course on how to balance chemical equations. Thank you very much.